How to write the formula of ionic compounds. Ionic compounds are composed of metal ion, positive ion, and the non-metal or the negative ion. So to write the formula first is to write the cation or the positively charged ion on the left side and the anion or the negatively charged ion on the right side. Then crisscross the oxidation numbers or the charges to make them subscripts so that the net ionic charge of the formula is 0, meaning the sum of the positive and negative charges equals 0. So example, Na1 positive is written on the left and O2 negative is written on the right. So 1 positive plus 2 negative is not equal to 0. That is why there is a need to crisscross. So these two oxidation number will become the subscript of Na, and this one will become the subscript of oxygen, doing the crisscross. So the formula is Na2O. Check whether the net ionic charge is 0. This subscript 2 multiplied by 1 positive is 2 positive, and this 2 negative multiplied by 1 subscript is equal to 2 negative. So this is equal to 0. Next example is Ca2 positive is written on the left and Cl1 negative on the right. So obvious that the 2 positive and 1 negative net charge is not equal to 0. Therefore, we have to do the crisscross. So these two crisscrossing to Cl and 1 crisscrossing to Ca, the formula now is CaCl2. Another example is aluminum on the left, 3 positive, and iodide on the right, 1 negative. Doing the crisscross, this 3 becomes the subscript of iodide and 1 becomes the subscript of aluminum. So the formula is Ali3. Now, remember not to crisscross if the oxidation numbers are numerically the same. Why? Because the net charge is already equal to 0. Example, Ca 2 positive and O2 negative, so equals 0, right? Therefore, the formula is simply CaO. Like this one, aluminum is 3 positive and phosphide is 3 negative, equals 0. Therefore, ALP is the formula. So do not forget, again, if the oxidation numbers are numerically the same, do not crisscross. Now, let's have polyatomic ion. Polyatomic ion consists of more than one atom. That is why it is called poly. The prefix poly means more than one. So, if the polyatomic ion after crisscrossing has a subscript greater than 1, enclose that polyatomic ion with a parenthesis. Let us have an example. So Ca here is 2 positive and hydroxide here is 1 negative. So we have a polyatomic ion here, OH, which is hydroxide, composed of oxygen and hydrogen. Now, after crisscrossing, these two is now the subscript of OH and 1 is the subscript of Ca. Now, because the subscript of polyatomic ion is greater than 1, therefore it has to be enclosed in a parenthesis. That is why the formula is Ca parenthesis OH parenthesis 2. So remember, this is wrong. This is the one correct. Another example is NH41 positive polyatomic ion, because it is composed of nitrogen and hydrogen atoms. NH4, 1 positive. Another polyatomic ion is CO3 carbonate. The charge is 2 negative. So after crisscrossing, this 2 becomes the subscript of NH4. So that is why it has to be enclosed in a parenthesis. And CO3 is CO3 without a parenthesis because the subscript is 1 after crisscrossing. Another example is this one. Al is 3 positive and CO3 is 2 negative. So after crisscrossing, CO3 subscript is 3. Therefore, you have to enclose it with a parenthesis. And Al, the subscript becomes 2. So the formula is Al2CO3. Now note, do not ever change the subscripts of the polyatomic ion. So look, the polyatomic ion, NH4. See, it remains NH4. CO3, see, CO3. In the formula, CO3. And do not involve them in crisscrossing. Do not involve the subscript of the polyatomic ion in crisscrossing. They remain unchanged. Okay, here are the symbols of common ions in the periodic table. You have group 1. Take note, all of them have 1 positive. Group 2, all of them have 2 positive. And group 3, 3 positive. Group 15, 3 negative. Group 16, 2 negative. And group 17, 1 negative. And the name of ions from group 1 to 2, 3 is the same as is their metal name. For example, Na1 positive is sodium, K1 positive is potassium, aluminum, Al3 positive, and so on and so forth. Now, the name of anions from group 15, 16, and 17 simply change the ending to IDE. So we have chloride, oxide, iodide, fluoride, bromide, sulfide. And these are the name and symbol of common polyatomic ions. Ammonium, NH41 positive, carbonate, CO3 2 negative, oxalate, C2O4 2 negative, permanganate, MnO4 1 negative, phosphate, PO4 3 negative, sulfate, SO4 2 negative. Remember, the subscripts must never be involved in crisscrossing. They remain unchanged. It's only the oxidation numbers that are involved in crisscrossing. So let us practice. Write the formula of the following compounds. Ammonium carbonate. So the first step is write the cation on the left and the anion on the right. So ammonium, the symbol of ammonium is NH41 positive. Carbonate is CO3 2 negative. Cation on the left, anion on the right. So crisscross, and we have NH4 parenthesis 2 CO3. Do the crisscross, oxidation numbers become the subscripts. Number 2, sodium sulfate. Again, cation on the left, anion on the right. So cation Na1 positive, SO4 2 negative on the right. So do the crisscross, Na2SO4 is the formula. The oxidation number becomes subscripts. Number 3, magnesium oxide. Again, write the cation on the left and ion on the right. So the cation is Mg2 positive and O2 negative is the anion. No need to do the crisscross, remember, because the net charge is equal to 0. Therefore, the formula is simply MgO. Remember, no crisscrossing because the sum of the charges is equal to 0.